Why, hello. So today we're going to look at trigonometric ratios and using them to solve for angles or find the measure of angles in right triangles. To do this, you would first start off by drawing your triangle. If it was given to you as a word problem or as in sentences, you would translate that to a drawing of the triangle. And then from there, you would set up the proportion, the trig ratio, the equation, depending on the information given. So if you're given opposite and hypotenuse, you would use sine. If you're given adjacent and hypotenuse, you would use cosine. If you're given opposite and adjacent, you would use tangent. And then you would solve for the unknown. So it's the same process that we use for the finding the sides of triangles using trigonometric ratios and right triangles. So let's begin. We already have our triangle drawn for us here. The angle is x. So based off that angle x, let's label our sides so we can see which trigonometric ratio we would like to use. So from x being here, first and foremost, I know the hypotenuse is over here because it's opposite of the right angle and because it does not touch the right angle at all. So this is my hypotenuse. Okay. Now from x, I know that this side, the 7, is opposite because it doesn't touch it at all. And this side would be my adjacent side. So what information is given? Opposite and hypotenuse. So which trigonometric ratio would we like to use? Well, we have opposite and hypotenuse, so therefore we use sine. Okay, so that means that sine of the angle equals opposite over hypotenuse. Okay, that still holds true. Now, how, in this case, what's the angle? Well, the angle we don't know is x. So we would do sine of x. And sine of x would equal the opposite side, so 7, divided by the hypotenuse. Now, many of you are going to be like, well, how do I find x then? Will I divide by sine? Well, sine is a function. It means you have to input something into it. So we can't just divide by sine and that solves for x. So what we have to do is, just like with everything else, we always use an inverse operation. To undo addition, we use the inverse of that, which was subtraction. To undo subtraction, we use the inverse of that, which is addition. To undo multiplication, we did the inverse of that, which was division. To undo division, you guys understand where I'm going with this. You always have to use the inverse operation. Well, there are inverses of each of our trig functions. And honestly, we just call them inverse blah. So, for instance, the inverse of sine is inverse sine, sometimes called arc sine, sometimes seen as sine to the -1. For cosine, it's the same thing. We have inverse cosine, arc cosine, cosine to the -1. For tangent, we have inverse tangent, arc tangent, or tangent to -1. They all mean the same thing. So I'll write that out here. So that's sine to the -1, also known as sine inverse. It's inverse sine. And then the last one is arc sine. So all three of these are synonymous. They all mean the same thing. It's the inverse function of sine. And so in order to solve for this, we would do the inverse of it. So I like to denote what it actually looks like. So this is sine to the -1 of sine of x. I'm going to write that so we have more room so you can all see it together. So this would be sine inverse of sine of x equals sine inverse of 7 over 63. And so I take sine inverse of both sides, and that undoes the sine, and I'm left with x equals the inverse sine of 7 over 63. Okay? Which, at this point, I can enter this into my calculator. Now, some of you will have this button that you see by itself. Some of you will have to hit maybe another key before you can hit that, a shift key or a second, and then hit the sine key. Some of you may have to find it, but it's there available to you on your calculator. So if I did this on the calculator I have, if I did inverse sine of 7 over 63, I would end up with x equals 6.3794. Okay, and that's as far as my calculator will go. So that's what I'm going to stick to. So 6.3794. So that's what I got for x. Okay, so we'll see that with cosine and tangent as well. We're going to look at two more examples. So first and foremost, though, we draw a triangle. You label your sides opposite and hypotenuse or adjacent based off the information given, based off the angle you're looking for. You decide which trig function you're going to use or trig ratio you're going to use based off of the given information. Then you set up your equation, substitute your values in, and you solve for the unknown. If you're looking for the angle, you will have to use an inverse function. You will have to use inverse sine, cosine, or tangent. You will have to. So in this case, we use the inverse, and as you can see, we quickly get to our answer. Okay? All right, so you can pause now if you need to for this one. So I'm going to go on to cosine now. Okay? So I was looking at an example that's going to involve cosine. Okay? Try my best to draw the triangles differently so you can see them in different angles. I find myself usually drawing the same one, no. So this is a little different here. So let's find x again. This time I will give you the number 3, and let's put 4 here. Okay, the other side's not 5. Okay. So how do we solve for x? Well, first and foremost, we draw a triangle, which is already given to us here. The second thing we're going to do is label our sides based off the angle. So the angles here given, we know that the hypotenuse is always opposite of the 90-degree angle. It's the side that doesn't touch it. So here's our hypotenuse. And that makes this side our opposite. No. This side over here would be opposite because it doesn't touch that. So a 3 would be adjacent. So we have our sides labeled. We have, from this, we know we have an angle and we have the adjacent and the hypotenuse. Which trigonometric ratio uses adjacent and hypotenuse? That's right, it's cosine. So we would do cosine of x equals the adjacent over hypotenuse, or the angle. You guys are getting the hang of it now. So we would get cosine of x equals 3 over 4. So substituting our values in for the angle and for adjacent and hypotenuse, we get cosine of x equals 3 over 4. All right, how do we solve for x? We use the inverse cosine, cosine to -1, or arc cosine. They all are the same thing. So this time I'll write arc cosine. So arc cosine of x equals arc cosine of 3 over 4. So arc cosine of x equals arc cosine of 3 over 4. So because these functions are inverses of each other, they cancel each other, or they make the other one go away. So we're left with x equals the arc cosine of 3 over 4. And if I were to use my handy dandy calculator, if it stays handy dandy, we end up getting that x is approximately 41.4096. Don't know why it keeps doing that, but 41.4096 would be what we would get for the angle for x. Now, if I wanted to find the other angle, what I could do is, I know that these two angles have to add up to 90 because they're complementary angles, because the sum of the angles in a triangle has to be 180 degrees. I could just subtract 90 from this and I would get the other angle. So given any two pieces of information about a triangle, with one of them, at least one of them being a side, you can find out everything else about the right triangle. If you have a right triangle and you're given at least one side and then one other piece of information, you can find everything else for the right triangle. Isn't that great? Isn't that cool? You can find out so much from just 2 pieces of information given to you. That's cool. There are 1, 2, 3, 4, 5 things to know about it. So you can find the other 3 from just 2. As long as one of them's a side. Okay. So that's using cosine. And we saw how you can use the inverse cosine or arc cosine or cosine to -1 in order to find the angle. Let's look at one more example, and you probably figured out which trig function we're going to use. So pause if you need to. Sorry about that. Okay, so let's see. Doesn't really matter which one we use in this case. I'll just put it there. So for here, we want to find tangent. Oh, well, we're going to use tangent. So we drew our triangle from the angle given. Let's label our sides. From here, we know that this is our opposite side. This is still the hypotenuse because it's opposite of the 90. And this must be the adjacent side. So which trig function uses opposite and adjacent? That's right. Tangent uses opposite and adjacent. So tangent of the angle would be opposite over adjacent. We end up seeing that tangent of x would equal 3 over 9. So tangent of x equals 3 over 9. Okay, because tangent is opposite over adjacent, we label our sides based off the angle given to us. All right, from there, how do we get rid of tangent? We must use the inverse function of it, which this time I will write it as inverse tan of x, or tangent of x, equals inverse tangent of 3 over 9. And if you wanted to reduce that first to 1/3, if you're wondering about why didn't I do that earlier, you can. You can. It's perfectly fine. Most of the time, this is quicker for people just leaving it how it is instead of trying to reduce it first and then plug it into the calculator. Because you don't have to reduce it and then plug it in. You can just go straight to plugging it in and be done. So inverse tan and tangent will undo one another, so you'll be left with x. And we get x is the inverse tangent of 3/9. And so when we do that, for x, we're going to do the inverse tangent of x. So inverse tangent of 3/9. We end up with 18.4349 approximately. And so that's the angle x there. Given the opposite and the adjacent sides, we were able to find out what the angle was by using inverse tangent. Okay. So we looked at how you can use each one of these examples, sine, cosine, and tangent. Given a triangle, a right triangle looking all kinds of different ways, you can find an angle if you're given 2 sides. Isn't that great? All right. So you have learned how to do pretty much everything you can with the right triangle at this point. You can incorporate all of these tools together with similar triangles, with the Pythagorean theorem, with finding the angles, finding the sides. You put all of it together. That's a wonderful thing. So that's trigonometric ratios and finding angles using trigonometric ratios. Signing off. I'll see you again soon.